Hi, welcome to the class. Today we will do few numericals based on combination of resistors, that is resistors connected in series and resistors connected in parallel, right? So let's begin with the first question. Here is the diagram. So here you can see there are number of resistors which are connected in the circuit. So the resistor is R1, then we have R2, R3, R4, R5, R6, and then they are connected with a battery. So this is a cell, and with the help of a ammeter. So ammeter is a device which measures current. It measures, right? And in this case, in this question, it is given that the ammeter has no internal resistance. It does not have any internal resistance, whereas this cell has a internal resistance. It has a internal resistance, correct? So the internal resistance of this cell is given. I have given it a denotation as R small r, which is equal to 1 ohm, right? Now the very first task is to find out that what all resistors are connected in series or what all resistors are connected in parallel, correct? So in this question, it will be a detailed one because I am making you understand that how to figure out and how to identify which all are connected in series and parallel. But later on, you can, when you master these questions, when you practice these questions really well, later on you can do them directly as well, right? So this is the cell. Current I will start flowing from the positive of the cell. It will start moving. I current is going. With R1, I current is passing. But at this point, you can see the current has option to travel in two different paths. So it will travel in two different paths. So the current which is coming here, let me name it as I1, and the current moving in that direction, let me name it as I2. So I1 will come here, that I will talk to you later on regarding I1. I2 will start moving in that direction. I2 passes through R2, and then I2 passes through R6, and then I2 passes through R4. As you can see the same current is passing through R2, R6, and R4. And what is the same current? I2 is the current. I2 is the current passing through R2. I2 is the current passing through R6, and I2 is the current passing through R4. So with R2, R6, and I4, R4, same current is passing. So how they are connected? So they are connected in series, right? So R2, R6, and R4 are connected in series. And why they are connected in series? Because through them the same current I2 is passing, right? So if they are connected in series, what will be their total resistance? So RS, resistance connected in series, will be R2 plus R6 plus R4. RS will be equal to R2 plus R6 plus R4. So RS will be equal to, how much is R2? It's 7 ohm. So this is 7 plus R6. R6 is 5 plus R4. R4 is 12. Then we have RS is equals to 12 plus 7, 19. 19 plus 5, that is 24 ohm. So when they are connected in series, their net resistance is given as 24 ohm. So when R2, R6 and R4 are connected in series, their net resistance is given as 24 ohm. So now what I am going to do, the combination of these three is equal to 24 ohm, right? I am going to remove these three, and instead of these three, I will just put a single resistor like this. This single resistor is RS, which is equal to 24 ohm. And what will be the current passing through this RS? Same current will pass through RS as it was passing through R2, R4 and R6. So current which was passing through R2, R4 and R6 was I2. So the same current will pass through with RS. So the current passing through this is I2. Now as you can see that with R5 I1 current is passing, with RS I2 current is passing. So is the current same through these resistors or is the current different? So the current is different. So how they are connected? They are connected in parallel. So they are connected in parallel. Therefore, for parallel combination we have 1 upon Rp is equals to 1 upon Rs plus 1 upon R5 plus 1 upon R5. If I write it 1 upon Rp is equals to 1 upon Rs. How much is 1 upon Rs? 1.24 plus how much is R5? 1 by 8. 1 by 8. So 1 upon Rp is equals to LCM would be 24. So if I write it, it will come 183. So this will be 4 upon 24. If I take the reciprocal, so 1 upon Rp is equals to 4 upon 24. Why I have to take the reciprocal? Because I want to calculate Rp, not 1 upon Rp. So Rp will be equal to 24 upon 4, which will be equal to 6 ohm. So the sorry, this is Rp. So the combination of these two, which two, Rs and R5, gave me a single resistor which is 6 ohm. So now instead of these two, I will have just one resistor, and that one resistor will be 6 ohm, and that will be Rp. So this is Rp, which will be 6 ohm. Now guys, what is the current passing through this Rp? The current passing through Rp would be the same as was passing through Rs. So current passing through Rs was I2, and the current which was passing through R5. So here we had earlier R5. So the current passing through R5 was I1. Current passing through Rs is I2. So I1 plus I2, I1 plus I2 will give you I, total I. So the current passing through this is I1 plus I2, and it is total current in the circuit, which is I, right? So now you can see I is passing through R1, I is passing through Rp, I is passing through R3, and I is passing through small r. So then the total resistance R total will be equal to how much? R1 plus Rp plus R3 and plus small r. What is small r? It is the internal resistance of the cell, right? So this will give me R total is equals to R1 3 plus 6 plus 2 and then plus 1. How much is it? 9, 10, 12. So it is 12. So this is equal to 12. So how much is the total resistance in this circuit? 12 ohm. Now if you want, you can remove all these resistors and just put a single resistor of 12 ohm. But no need to do that, because now we have almost figured it out, right? So now what we are going to do now? We are going to take the total resistance, which is 12 ohm. We know that this is the total resistance in the circuit, which is 12 ohm. Potential is 6 volt. From Ohm's law, we have V is equals to IR. So I is equals to P upon R. So I is equals to P upon R. What is V? 6. How much is R? 12. So I is equals to how much? 1 by 2. So I is equals to 0.5. What is the SI unit? Ampere. So this much current is passing through the circuit. So of course the same current will be shown by the ammeter, because it measures the current in the circuit. So I is 0.5 ampere and the same current will be shown by the ammeter, right? Now let's begin with the second numerical. So here we have another question. In this question, a cell is there whose potential is given 84 volt. You all know that this current will start flowing from positive terminal of the cell. It will come up till this point. Now here R1 resistance of 100 ohm is connected, and with this resistance voltmeter is connected in parallel. Voltmeter is always connected in parallel. Before this question, ammeter was connected and it was connected in series. So ammeter is always connected in series. Voltmeter is always connected in parallel. So voltmeter is given whose resistance is also given. Its resistance is 400 ohm. And then one more resistor is given 200 ohm. So in the first part of the question, I have to find reading of the voltmeter. I have to find the reading of the voltmeter. This I have to do in the first part. So when the current I will come at this point, it will of course divide like this, I1 and I2. And again at this point, this I1 and I2 will combine back to form current I. And therefore the I current will pass back. So I will pass through I. So this is the whole circuit. So now I have to find the reading of the voltmeter, and voltmeter and this resistor are connected in parallel. And voltmeter measures potential difference. Voltmeter measures potential difference. It means I have to find out how much value of potential it is showing. Correct? How much value of potential it is showing, that I have to calculate. Whatever value of potential this will show, the same potential will pass through this. Why? Because they are connected in parallel, and in parallel potential remains same and current gets divided. Correct? So we can see that these two are connected in parallel, and the combination of these two will be connected in series with this one. Right? So let's do it. So I have R1 and R, which is the voltmeters, connected in, how they are connected? Parallel. Why they are connected in parallel? Because current is getting divided. So what will be their net resistance? 1 upon Rp is equals to 1 upon R1 plus 1 upon R. So 1 upon Rp is equals to 1 upon R1. 1 upon R1 is 1 by 100 plus 1 by 400. So 1 by Rp will be equal to 400. This will be 4 plus 1. 1 by Rp will be equal to 5 upon 400. And Rp would be equal to 400 upon 5. So this will be 80 ohm. So how much is Rp? 80 ohm. Now if you want to remove these two, if you want to erase these two for the practice and then put it just Rp, you can do that, right, in your practice till the time you get perfect in these kind of questions. But right now I will not do it, right? So Rp is 80 ohm. So if Rp is 80 ohm, so then this Rp, this single resistor will come instead of these two. This Rp will be connected with R2 in series. So R2 and Rp are connected in series. Why they are connected in series? Because same current is passing through them. So then R net, which is the net resistance, will be Rp plus R2. So R net will be equal to 80 plus R2 is 200. So R net will be equal to 280 ohm. This is the net resistance of the circuit, whole circuit. Now resistance is this. Potential is 84. Using Ohm's law, V is equals to IR. I can calculate the I. I'll tell you why I am calculating the I. So I will be calculated 84 upon V upon R, 280, and this will give me the value of 0.3 ampere. So I in the circuit, total current in the circuit is 0.3. Correct? Now with this, with RP is having the same current 0.3 and RP is the combination of this one and this one. Don't forget that. Correct? So using this RP resistance 80 ohm and using that current, I can calculate the voltage through these two. So the voltage through RP. Remember that RP is the combination of R1 and R, and they both are connected in parallel. So whatever voltage will come through the combination, the same voltage will be through R1 and V, right? So voltage through RP. So voltage through RP will be RP is equals to 80 ohm and I current through is 0.3 ampere. And then V is equals to IRP. I is 0.3 into 80 and this is volt. Remove this point. 8 3 is a 24. So this voltage will be equal to 24 volt. So 24 volt is the voltage passing through RP and same voltage will be passing through R1 and this R. Because RP is the combination of R1 and R and they are connected in parallel and in parallel they have the same voltage. The very first part reading of the voltmeter will be 24 volt. So 24 volt will be the reading of the voltmeter. So this was one more type of question. I'll give you one as homework, right? So we'll move to the next question now. So this question I'll give you as homework. I'll explain you the question. And the question says find reading of the voltmeter. Diagram is there on the board. Let me just explain the diagram. Again we have a cell whose voltage is given 40 volt. Guys, in these type of questions, please keep one thing in mind that here in this question and in the previous one also, the battery or the cell was having no internal resistance like the first one. If they have the internal resistance, we have to consider those internal resistances also. Okay, so please keep this thing in mind. In the first question, ammeter was having no resistance, but in the second one, voltmeter was having a resistance. In this, voltmeter has a resistance, but battery does not have. In the first one, ammeter was not having, but the battery was having. So we have to consider these resistance in consideration when we are solving these kind of questions. Anyway, now this is voltage given 40 volt of the cell. R1 is given 200 ohm, R2 is given 880 ohm, and this R, which is 300 ohm, and it is the internal resistance. It is the internal resistance for the voltmeter. It is given like this. So if you see, the question is the same only, previous one, and in this case you have to find the reading of the voltmeter. I will tell you the answer and it will be a part of your homework assignment. So this voltmeter reading V is equals to 4.8 volt. Now try to find it out. If you do not get it, ask me in the class, or you can ask in the comment section also. So this will be the answer, 4.8 volt for this part, which will be the reading of the voltmeter, and you have to solve this question. Very important question, right? Thank you.